Okay, today we're going to talk about 3D geovisualization. And the first question we want to discuss is that why we need 3D geovisualization, or more generally, why do we need 3D visualization? Because simply our world is 3D, right? Our world is a 3D world that does not exist on a two-dimensional surface, right? So visualize, analyze, and communicate by enriching your data and ideas with the context of the world around us. Of course, this is a marketing expression of the necessity of 3D geovisualization by Esri. Of course, they are a huge enterprise. They want to promote 3D visualization, geovisualization. And the why 3D GIS is the future. That's some people's argument. The world we live is a three-dimensional world. Yes, for sure. So why do we map it and analyze it in just two dimensions? And now we have the technology to 3D visualization, a lot of things, why not? And sharing 3D data had been difficult, but this is not the case anymore. Today we have internet, we have cloud drive, cloud computation. Uh, Gathering data and sharing data, they're not problems anymore, at least for data sets that are not very big, it's not a problem. So why are we still flight mandate? We should go to a 3D geovisualization world. I partially agree with this argument why 3D GIS is the future, but I do not think that 3D geovisualization is a must for every geovisualization or GIS project. We should not abuse it. So later we will talk about what we will gain and what's the disadvantages of 3D geovisualization. And the disadvantages, they are the primary part of this topic. You will see that 3D geovisualization is good for sure, right? Because it's closer to our 3D real world. But you will also see that there are a lot of issues you need to be very careful with when you are trying to 3D geovisualization. And we should can I say, we should deal with 3D geovisualization carefully instead of simply abusing it and using it everywhere. Okay, so let's get started. So in the past, 3D visualization, not geovisualization. Okay, be careful with the difference. Visualization is a more broad concept. Okay, 3D visualization has been there for decades. In 1970s and 80s, computer programmers they had tried to use 3D visualization to create 3D video games, right? But that was not geo visualization. Back then, of course, you can use boxes. For example, those boxes or cubes in this figure to represent buildings and other geographic entities if you want. But the problem is that you cannot link them with real world coordinates, right? Just like here, 3D visualization of the past used to require that you stripped data of its coordinates. Once processed, these models had no reference in the real world and were no more than standalone objects. Okay, it means that we have had the technology for decades, but in the past we cannot link these small boxes to real world latitude and longitude coordinates. But now we have a lot of GIS tools that can help us connecting 3D models to real world coordinates. Okay. So yeah, let's start with today's uh, main characteristic that advantages and disadvantages of 3D geovisualization. Okay, so what is gained by going from 2D to 3D? What are some problems with 3D views, right? So for the first question, we will discuss the advantages of 3D geovisualization. For the second question, it's about disadvantages you should be careful with when you are going from 2D to 3D. So pros or advantages, right? Additional display space, because when we're using 3D geovisualization, we're actually adding the third dimension into our GeoVis, or you can simply say the third axis. So we have extra space. And the secondly, displaying additional data variables, because we have the third dimension to address. We can use it to show more variables, okay? And providing a familiar view of the world, of course, especially for those people who do not have strong geographic information background. 3D geovisualization will be, in most cases, easier for them to read, okay? Because 3D GeoVis is closer to real world. At least, I mean, after all, it's 3D, right? And resolving the hidden symbol problem. I think that's the most valuable advantage of 3D geovisualization, because in a 2D map, a lot of stuff, I will say some examples, they are hidden because we only have 2 dimensions. But in a 3-dimensional space, you have more freedom. You have more freedom to show more symbols. Okay, let's go through them one by one, okay, and see some examples. Firstly, additional display space. I'll show you this example directly. It's easy to understand. So now we have a 3D visualization, geovisualization here. We have some boxes. Of course, you can tell that each box here is a building. So this is a 3D geovisualization of an office park. So all those boxes, they're set there. Of course, there is a surface. That surface is a real world ground surface, right? And you can see subsurface, below surface, there are a lot of straws. I cannot rotate it here, but you can say straws or bars. You can say you can call them whatever you want. All those small bars, they have different colors, right? And each color is a segment of the straw, and each segment has a specific length, right? So each straw here is colorful. Each straw here, according to the author, it's representing some geological ratings, right? And below the surface, if it was a 2D geovisualization, obviously you cannot show these bars, I mean, under the ground, right? But here, since we have the third dimension, the vertical axis, it's not a 2D map anymore. You can show them in the extra space, the third dimension, right? So additional display space. And the drawback imposes demand for interaction. What does it mean? I've mentioned it actually, because now you can say some of those bars, they are hidden, they are blocked by buildings. They're blocked by other bars or other straws. So in order to solve this problem, you need to make sure that this geovisualization can be rotated, which means that you can click and drag to make sure that you can look at this same geovisualization from another perspective. This is called interaction, click and drag. This is a very common operation today as we're using smart devices, right? So that's the disadvantage. You have to invest more resources to make sure that interaction is implemented, and to make sure that your users can look at your geovisualization from different perspectives, from different directions. Okay. Secondly, displaying additional data variables. Actually, this is the result of having additional display space. Here is another example, 3D view showing various types of commercial property in North London with a semi-transparent horizontal reference plane used to highlight locations with more than 5 properties. So here, again, it's a 3D geovisualization. We have the third dimension or third axis. We can see a lot of bars erected from the ground, And I mean, thanks to this third dimension, we can show more visual variables here. For example, along each bar, there are a lot of pies, right? Each pie has multiple visual variables, can be used to address multiple actual variables, right? For example, the color of each pie can be used to address one variable. I mean, the size of each pie here can be used to address the second variable. And the thickness, or you can tell, I mean, you can call it the height of each pie can also be used to address the third variable. So you can add as many as you want, but I would say it's not a good idea to add more than 3 variables into one geovisualization. But no matter, I mean, displaying additional data variables is another, say, advantage of 3D geovisualization. Although the 3D geovisualization can be very complex, can be very hard to read, just like this. It's kind of hard to read, right? We have so much information here. But yeah, it's an advantage. And more example here, we have seen this map before. It's called catogram, right? We sacrifice the shape and the area or the size of each country to show the population of each country, using space to address population. But if we have the third dimension, we don't have to distort the shape, the size of each country here. Here is an example. Now we have a very typical chloroplast map using grayscales to show Michigan elderly percentage in 2000, right? If we have a lot of counties here in the state of Michigan, if it is dark, it means that the percent of elder people in that county is high. Obviously, if you have a light gray or even white for a specific country, it means that the percentage of elder people is low. So this is a 2D geovisualization, right? Showing you the percentage of elder people in different counties. But if we want to use space to address the percentage, of course we can use catogram. But if we have 3D technology, we can do this. It's called Prism map. It's a 3D version of the map on the left. And you can see that besides grayscales, each county has a specific height, and that height is proportional to its percentage of elder people in that county. So here, we didn't use the size, the shape of, we didn't sacrifice the size and shape of each county to address percentage elder people. Here we use the third dimension, the height of each county. You can see here, this county has 20 to 25% of elder people living within. So it has the highest height, right? So here, yeah, it's advantage. We have extra space to address something we cannot in a 2D map. But the problem here is also obvious. Some counties, they are blocked by others. They are blocked by others. And here we're using something called redundant mapping because the percentage elder people has been addressed by grayscales. And again, we use the height of each county to redundantly address it again. And in order to address the problem I mentioned before, blocking problem, again, we need interaction. We need to make sure that our users can click and drag to look at this same geovisualization from different perspectives. right? So yeah, another example for um, gaining extra space and addressing extra variables. Next advantage, providing a familiar view of the world. I think this is obvious, right? For example, on the right side, we have the 3D geovisualization of Manhattan in New York. Because we can tell from all those famous buildings, New World Trade Center, and I think that is Empire State Building. Not very sure, but we can tell it's a metropolitan area with a lot of skyscrapers, right? So this is good, like I said, especially for people who don't have very strong GIS background. It's easier for them to recognize what they are looking at. But the problem is also obvious. You will invest a lot more resources into your geovisualization to make this happen. Firstly, you need to have a powerful computer to render all those models for sure, right? And then you may need a very good designer to create these models to make them look real. I mean, when I'm looking at this building, I'm guessing it's Empire State Building. But if you let me create a model of Empire State Building, you would not see it as Empire State Building because I'm pretty bad at drawing and painting and creating models, right? Which means that you have to pay more to ask some people to do it for you, right? So advantage, yes, a very familiar view of the real world to people, but you have to invest more to make that happen, right? And resolving the hidden symbol problem, example here. So we have a 2D map here showing you a 2D vertical view of family classes in the East End of London in the late 1880s. So each small circle here is representing a specific family. And since we're talking about family classes data, it's something we call it nominal data, category data, right? It's not quantified data, it's qualitative data. Each family is assigned a specific class. Class 1, class 2, class 3, class 4, etc., etc. Each class has a specific color, that's it. So now, yeah, with a 2D map, we can only show family class. And what if I'm telling you that each circle here is not actually a circle, it's a bar, it's a straw erected from the ground. You can only say circles here because you're looking at the area from right above. If we change it to a 3D geovisualization, maybe this is the fact. If this was the fact, you can see that a lot of information, much information is hidden here because you are looking at this area from right above. If you're looking at it from a side, if you can rotate that to the visualization to make it 3D, this is the result, right? We have more colors for one single family because different family members, they may belong to different classes. This is how 3D geovisualization is trying to solve the hidden symbol problem. But I would say it solved some part of the problem and it created even more because a lot of bars or straws, if you want to call them, they are blocked by others, right? So again, I have to emphasize this. Interaction is pretty important for 3D geovisualization. Because if your 3D geovisualization is static like this, you cannot drag, you cannot rotate it, then maybe you're bringing even more hidden symbol problem here, right? So I will just stop here, and from next part of the video, I'm going to discuss the problems of 3D geovisualization. Okay, thank you. I'll stop here.